Hi, this is All This Science, the science podcast that describes an interesting aspect of science in 5 minutes or less. My name is Abi.
And my name is Tori.
And we are your guest podcasters for this episode.
Supercooling. So the question of the hour, how is it possible for water to turn from a liquid to a solid in such a short period of time?
Well, it's the supercooling process.
The process known as supercooling occurs when a liquid is cooled to a temperature below its freezing point without the liquid actually freezing and turning into a solid. According to Science Daily, a liquid below its freezing point will crystallize in the presence of a seed crystal or nucleus around which a crystal structure can form. But if the liquid does not have this nucleus, the substance can avoid freezing and stay in the liquid phase. This is what happens to water in our experiment.
Let's start by discussing the different states: solid, liquid, and gas. The molecules in a solid compound are close together and have a limited amount of energy. Gas molecules have the largest amount of energy, as well as the most space in between the molecules that are moving at a rapid pace. Liquid molecules have a medium amount of energy and a medium amount of space between them.
Now, back to the experiment. As we put the water bottle in the ice and the temperature of the water begins to decrease, heat leaves the water, decreasing the energy of the molecules, bringing the water compound closer to a frozen state. The water will not freeze because of the lack of time it has under the conditions.
When you hit the water bottle against a surface, the close to frozen water molecules all rush to the bottom of the water bottle, which applies pressure on these molecules. Because of the water molecules, they do not have enough energy to detach from one another. The liquid molecules turn into solid molecules. Now, hopefully your computer does not freeze right now, because this podcast is about to get fun. We will explain how to do the experiment, and then you'll be able to do it yourselves.
Get ready for some crazy action. The first step of this experiment is to gather your supplies. You will need 4 things: a water bottle, a bucket full of ice, some salt, and a thermometer.
Place the ice and the salt into the bucket. Make sure that the bucket is deep enough to cover at least 3/4 of the water bottle.
Why salt? What does that do? Does it help the freezing process?
The salt interferes with the dynamic equilibrium that the water reaches at 0 degrees Celsius. When the water reaches 0 degrees Celsius, there is an equal number of liquid and solid molecules. The salt cannot affect the solid molecules, but it can affect the liquid water molecules. The liquid water molecules can be replaced with the salt molecules, which will mess up the 1-to-1 balance. There will be more solid molecules than liquid molecules, which will help decrease the time it takes to freeze something.
And then the water will try to reach equilibrium again, freezing even more molecules. Makes sense.
So back to the experiment. Once you have placed the ice, the water bottle, and the salt into the bucket, you'll need to get a thermometer.
Then, place the thermometer into the bucket right next to the water bottle. Keep an eye on the temperature. You will need the water temperature to drop -8 degrees Celsius. Make sure to keep the water from freezing, or else your experiment will not work.
Once you have reached the temperature of -8 degrees Celsius, set a timer for 10 minutes and leave the water bottle inside of the bucket.
And while you are waiting the 10 minutes, you can listen to some exciting more All This Science podcasts.
After 10 minutes has passed, take the water bottle out carefully, making sure not to shake the water. Hit the water bottle against the sturdy surface and watch the ice crystals form as the water changes from a liquid to a solid state before your eyes. The crystal should form from the bottom up.
You'll need to look closely because the water bottle will be foggy due to the freezing process.
And make sure that you have your video camera out to capture the result of the experiment. Show your friends. Maybe they'll want to work the magic too.
Thanks for listening to All This Science, and make sure to let us know how your experiment went.
Contact us at allthisscience@gmail.com with all of your questions and comments. Thanks for listening.